Alrighty, so I guess I should have gotten a piece of patty paper for myself. That would be... Okay, so let's draw this kind of shape here. Ooh, but it's got a line, so I should probably pass out those straight edges here too. So sorry about that, guys. Wait, you have straight edges. Never mind. Your mirrors all have straight edges on them. So let's just use our mirrors for straight edges, okay? We'll do that. It'll make it easier. So again, let's kind of do our best here to kind of recreate this little shape that we have on their reflecting paper. So I'm going to use a pencil because pencils write better on the wax paper. If you only have a pen, that's fine. You'll be, you'll survive. But okay, so I'll draw a line L here. Put some arrows at the end, and then I'll draw that little quadrilateral there, and I guess maybe I'll use a straight edge here for that too, just because, why not? Okay, and there's line L. Okay, so there's our little patty paper. Okay. And so to reflect this thing, we're supposed to fold, right, over line L. So go ahead, take your paper, and I'm going to fold this bottom half over here on line L. So make sure your fold is across line L there so that we're overlapping. So you want to be careful about how you fold your patty paper so that you do fold along line L there. Okay, so I think I did a pretty decent job. All right, we'll see here. And when you fold that patty paper, when you fold it on top, okay, you should be able to see your little quadrilateral through the fold. And so let's go ahead and at least trace the points there. Okay, I guess C is kind of hard to do because it's right on the fold there, but we can kind of get that. Okay, so I'm just going to trace those points. And we can open our patty paper back up and then use our straight edge here to redraw that shape. All right. And so, Maddie, all we did here was drew on our patty paper using our mirrors as a straight edge, drew a line, L, and then drew kind of like a quadrilateral that we then we're going to reflect. So we just drew this quadrilateral. Point C, you want to put on line L, and then just kind of, draw something like this. Okay, and then we folded our patty paper over top using the line L as our fold line, and then traced in the back there to get those points, and then redrew our shape in the reflection there. Okay, just like that. And when we unfold it, right, we have a reflection of that quadrilateral ABCD. All right. Of course, since it's been transformed, we want to name it. Okay. So, what will the name of this point right here be? B prime. Good, because it was transformed from B. How about this point right here? What is its name? A prime, right? And this point right here? D prime. And then C prime is the same location as C. So maybe I'll do like that. Okay? So there's a reflection. Wow, right? Is a reflection a rigid motion transformation? What do we say? Yes, right? The size doesn't change, the shape doesn't change. Okay? The one thing that does change that is a little bit different than from translations, right? Translations, the orientation doesn't change, but here the kind of orientation changes, right? If you go kind of like clockwise around your shape, starting at A, you go A, B, C, D, right? But if I start going clockwise around my shape, I do A prime, D prime, C prime, B prime. So the order of the points kind of gets a little messed up, all right? But it still is the same size, same shape, so we do call this a rigid motion transformation. But the orientation, though, doesn't necessarily stay the same. Okay? So now that we've got all that, all right, the next thing we want to do here is to draw segments to connect each vertex of quadrilateral ABCD to their images in quadrilateral A prime, B prime, C prime, D prime. So in other words, connect B to B prime, connect A to A prime, connect D to D prime, and well, C to C prime, I guess, but that's kind of a silly thing to do. Anyway, so draw little line segments there connecting those. See if I can do this in a different color, if it'll show up. I don't think it will, but I'm going to try. Do red. Yeah, it kind of shows up, okay. Okay. All right. So now that we've drawn those segments in, right? If you remember when we did translations, the segment from B to B prime, or A to A prime, or C to C prime, D to D prime, again in translations, right? The segment that joins a point and its image, they were all the same length. Is that true here? The segments that join a point to its image, are they all the same length? No. They're not the same length, right? BB prime clearly is shorter than AA prime, which is clearly longer than DD prime. And CC prime, there's no segment. All right. Is there anything we can say about these segments? Any interesting properties that kind of show up here? Okay, BB prime, AA prime, and DD prime are all parallel. That's right. How do they relate to line L there? Perpendicular, or they make a right angle, 90 degrees. Exactly right. Can we say anything more about line L? So we could say line L is perpendicular to BB prime, AA prime, DD prime. Can we say anything else about how those segments and line L are related? What do you say, Jenny? Line L, you could call it transversal of BB prime, AA prime, DD prime. Absolutely. Yeah, Avery?
Line L is like the midpoint, sort of.
Okay, so line L is a bisector, we could say.
Yeah.
Bisector. So we could call line L the perpendicular bisector of BB prime, AA prime, DD prime, right? And it makes sense that that would be the case, that it would be the bisector at least, because we took D and we reflected over line L. So D's reflection is going to be an identical distance in the exact opposite direction as D prime will be exact in the opposite direction as D is, right? A in the same sense, in the exact opposite direction, and B in the exact opposite direction there, its image. C, of course, doesn't move. Why doesn't C move? Why? Yeah, but so why is that though? Why is it that? Why does C and C prime end up being the same point? Because it's on the line of reflection. Exactly right. It's on that line of reflection. Okay. So, good. All right. I don't know if you want to maybe stick this into your book there or something like that to see later. Like maybe stick it in there. You can hold it in there or something. Okay. But that's what we wanted to kind of look at there. Okay. That's something there. So that's a little exploration we did with some reflections. Of course, we've seen reflections already a little bit using the mirrors and things. Okay. So let's turn the page here to page 74. Okay, so real quick at the top, just to make sure we're okay with this, a student claims that a figure and its reflected image always lie on opposite sides of the line of reflection. Do you agree? Why or why not? So again, a student claims that a figure and its reflected image always lie on opposite sides of the line of reflection. Do you agree? A figure and its image always lie on opposite sides of the line of reflection. Do you agree? So I hear yeses.
No.
Okay. You hear no's. Okay, so yeses, you want to explain? Okay, no's, you want to, Madison, you want to explain? Go ahead.
That you're reflecting it over the line.
Mm-hmm.
That means it's going to have to be on the other side because you can't reflect it over the line. It's not on the other side.
I got you. Okay. Jackson, what do you want to say?
If the image was in two different quadrants and it was reflecting over the axis, like it was in quadrant 1 or 2, and it was reflecting over the y-axis, and just switch sides.
Okay. So you're saying like if you had your image that like was like, I don't know, something like that,
Yeah.
okay, and you're reflecting over the y-axis,
Yeah.
okay. So a student claims that a figure and its reflected image always lie on opposite sides of the line of reflection. So this one I could see that, yeah, I can see what you're saying there, and then someone might argue, well, it's like, okay, but this piece that was in this section will end up over here, whereas this piece in this section will end up over here. But I see what you're saying there, okay. There's one other possibility here, though, too, right? So again, a student claims that a figure and its reflective image always lie on opposite sides. We just saw a situation, right, where a object and its reflected image did not lie on opposite sides of the reflection line. Yeah.
Be on top of the reflection.
Right. When it's on the line of reflection, there is no opposite. It stays where it is, right? And so that's another kind of counterexample to that too there. Okay. Cool. All right. So again, we already know what perpendicular lines are. We already know what perpendicular bisectors are. So we'll look here at the official definition for a reflection. A reflection across line L maps a point P to its image P prime. If P is not on line L, then line L is the perpendicular bisector of PP prime. If P is on line L, then P is equal to P prime, right? So if P is not on line L, then P prime, its image, is, I guess, a segment that joins P and P prime is perpendicularly bisected by line L. And then if it's on the reflection line there, like Q is, then it's equal to Q prime. It's the same spot. Okay. So we're going to look here. So one thing we're going to want to do, right, is to be able to do these kinds of reflections. All right. We have some tools available to us. Right? So we have the mirrors, for example. But it's also possible to kind of do this visually, I guess I want to say, if we kind of like are just careful with how we do it. So for example here, it asks us to draw the image of triangle ABC after a reflection across line L. Okay? So if you look here, we can kind of see, okay, from A to the line of reflection, I'll zoom in. Let me see if I can get this to work out better. That's as far as I can go. Okay. So what we can do here for this, to reflect this, is you can kind of see, okay, A, if we're going to reflect it across line L, we know it's going to end up somewhere over here. And in fact, we can actually kind of count. There's like 2 diagonal boxes it takes to get to the line L. And so we're going to go 2 diagonal boxes in the opposite direction there to get to A prime, right? So likewise for B, you can see it's 1 diagonal box away. And so we can go 1 diagonal box in the opposite direction from that line of reflection. And there would be where B prime would have to be. Right? Let me see if I can make this look better with the light. Yeah. And then C is 1, 2, and like a half. So we'll have to go half, and then 1, 2, and there's where C prime would be. Okay, there's where C prime would be. And so then we can connect those dots. I'm just going to freehand draw it. And there's our image. Okay, bless you. All right. Sometimes it's easier to do sometimes than others. Okay, so we have to be just a little bit careful when we do this. All right, but let's try another one here. Let's take a look at this one. Okay, I'm going to use a red pen so it stands out for the image here. All right. So letter B, draw the image of triangle ABC after reflection across line L. All right, so let's see if I can get this to fit on there. All right, so let's see here. Emmanuel, where is C going to end up? If we reflect it across this line L here, where will C end up? Yes, it's going to stay the same. We're exactly where it is. Okay, so that's an easy one for us to do, thankfully. Okay, so there's C prime. Okay, let's see here. Then A, if you look here, it's about, ooh, this one's kind of hard to see. So let's see here. So to do this one, you can kind of see, well, I don't know, to get like a perpendicular here, it's going to be something like that. So it's like down to right one. So we can also go like, I don't know if I like what I'm about to say here. So maybe what instead we'll do is let's use our mirrors, okay? Because I'm not really sure I feel comfortable saying where it's going to be. So to use your mirror, remember that you want to use the beveled edge on the bottom, right? That's what you want to use to line up your line of reflection. So you take your mirror, you're going to place it on top of your book and line up that line of reflection. And you should be able to see through there where B and A will end up, okay? And it might not be exact, but kind of pick the nearest, grid point there for when you do it. And it should line up okay. And of course, I chose a red pen, which is probably not the smartest idea. There it is. Okay. And then you can use your mirror as a straight edge if you want to create nice straight lines for your sides. Okay, like so. And of course, don't forget to label your points. Okay, A prime, B prime. Like that. Okay. In this particular graph, because of the way it's drawn and stuff like that, how can we check to see that, for example, segment A prime, how can we check to see that segment A prime is perpendicular to this line L here? With what we've got, how can we check to see that the segment A prime will be perpendicular to this line L here? What could we do to determine whether they are in fact perpendicular or not? So again, if I were to connect these and kind of maybe draw a line through there, but there's our segment A prime. How could I check to see that A prime is in fact perpendicular to this line L here? What could we do? How do we know if two lines are perpendicular? They make a right angle, right? But what else can we look at to determine if they're perpendicular? Madison? Okay, so if it bisects, we can see there that we can measure, right? A to there and A prime to there and see if it bisects. So yeah, the bisector part. But I'm talking about perpendicular, how these lines intersect at a right angle, right? How can we check to see if two lines are perpendicular? What do we know about perpendicular lines?
They have opposite and reciprocal slopes.
The slopes are opposite reciprocals, right? So we could count the slope here, right? To get from A to A prime, we have to go down 1, 2, 3, 4, and right 1, 2. So the slope of A prime is down 4 over 2 or negative 2 over 1 when you simplify it. The slope of line L, well, we want to be careful here and pick a point that's on line L. So like here, it looks like we go through this point and then this point. So it's up 1, right 2. Are the slopes opposite reciprocals? They are, right? And so A prime is perpendicular to line L. Okay? All right. Go ahead, try 5 and 6 there. Okay, you guys go ahead, do the 5 and number 6. Try those. You can use your mirror if you want, or you can just count if you want to try that. All right? But use your tools there at your disposal. Oh, shoot. You know what else I could have showed you? Duh, Mr. Widmeyer. Duh. Don't forget to label your points with the correct name as well. So I'll show you, there's number 5. Reflected there. And then I'm going to show you one other strategy that I can't believe I forgot to show, okay, which is you can also use your patty paper to do a reflection. So let me show you how to do that. All right. So again, so let's say, for example, here for number 6, that you want to reflect that triangle ABC. What you can do is just get a kind of like a space there on your patty paper where you can trace the shape. I'm going to trace points A, B, and C onto my paper like that. Okay. And then you also want to trace your line of reflection here. Okay, my recommendation, I like to put like little points at the tips of the arrows there. So right at the tip of the arrow there, right at the tip of the arrow there. Okay, and then you can use a straight edge if you want to kind of connect those 2 points for your line of reflection. It can be helpful. Okay. Like so. And then all we're going to do to reflect this is to flip our patty paper over and then reline up that line of reflection like so. And you'll see that the points on my patty paper go to grids. I'll go to grid points there. I'll just draw on the backs of those points so that they transfer, okay, right there. And then you can use the straight edge of your mirror to finish off the graph. Okay. So really 3 options there. You can use your mirror, you can count, or you can use your patty paper too to help you with some of these. Okay, there it is though. It's like a little butterfly. All right, moving on. So those are some options that you have right there. Of course, we also want to talk about reflecting in the coordinate plane, okay? And we've already talked about that, where I saw that happen kind of somewhat today, and we talked about those when Jackson talked about that double reflection in the warm-up there, okay? So here we have a table that summarizes coordinate notation for reflections on a coordinate plane, okay? So for example, if you want to reflect across the x-axis, well, we're going to take our coordinate xy, and it's going to become x negative y, right? If something's above the x-axis, it's got a positive y-coordinate, and it will reflect down to a negative y-coordinate. If something's underneath the x-axis, it'll have a negative y-coordinate, and it reflects up to the positive y-coordinate. And then across the y-axis, it's the x's that will become opposite from each other, right? X goes to negative x, y stays the same, though. And then we can also talk about reflecting over the diagonal line y equals x. Okay, results in this. Notice that the x and y switch to yx. And then if we reflect across the line y equals negative x, it takes xy, switches the y and x, and also makes those negative as well. Okay? So there's an example right here you can see where we reflect a figure with the given vertices across the given line. So it just says reflect those 3 points across the y-axis. It's super easy on the coordinate plane when you're reflecting across the y-axis there because it's literally just, if there's m, it's 1 away from the y-axis, so count 1 away again. There's m prime. 1 away for n prime, and then 1, 2, 3 away, so 1, 2, 3 away there for p prime. Okay, just reflect it over. Okay, it's going to be the same distance and stuff as well. All right. Let's take a look here at the line y equals, or we're reflecting across the line y equals x. So we'll plot the 4 points here. So D is 2, 0. Let me use a different, I'll use an actual like colored pen here. Okay, so there's D. E is 2, 2. F is 5, 2, so 5, 1, 2. And then G is 5, 1. Ugh. There we go. These books can be kind of hard to draw in. All right, now, we're going to graph the line y equals x. So this is in slope-intercept form, right? The y-intercept is 0. The slope is 1 over 1. And so there's my y-intercept is 0. I'm going to just graph the slope of 1 here. So this is kind of like my line of reflection right here. Okay. The book has us calculating where those points end up using like the table up there and the coordinate notation, right? Graphing across the line y equals x, we're going to just flip the x and the y's. But you can also like kind of just count in this case too. It's not that hard, right? Where will E reflect to? We're reflecting over the this is our line of reflection, right? Because the line of reflection is y equals x. Y equals x. So it's this line right here. So where will E end up? Stays the same. That's right. Okay, that's why I didn't say anything there. So E becomes just 2, 2 again. Okay. D, if we're going to reflect it over the diagonal line here, okay, it's 1 diagonal box away. So we'll go diagonal 1 away here to the point 2, or 0, 2, I mean. Graph my red here now. Okay. F is 1.5, so a half and 1 further away there. There's where F prime will go. There's D prime. And then G is 1, 2 away, so 1, 2 away. There's G prime. And if we connect our sides back together again, we can see the reflection there. So yes, you can memorize these coordinate notation rules if you want to. I don't think it's really necessary though. I think if you just draw the line of reflection in there, it's going to be pretty easy for you to go ahead and graph this. Okay? It's going to be pretty easy for you to go ahead and graph this. So it seems kind of silly to memorize those things. All right, questions on any of that though? All right, let's move on then. I'd like to have you guys try one. You pick 9 or 10. All right, on the next page there, you pick, do either 9 or 10. Okay, either one. Pick one and go with it. I'll do both. Okay, I'll do both. So pick 9 or 10, do one of those, and we'll move on from there. Bless you. Bless you. Okay. Anyone still need more time? We're all good? All right. So there's number 9 for you. Okay, reflecting across the x-axis with correctly labeled points. Okay. And there's number 10 then. Also, reflecting across the line y equals negative x. So negative x has a slope of negative 1 over 1, and then a y-axis of 0. So it goes through the origin, go down one, right one, down one, right one, down one, right one, all that stuff. And so there's your reflection there. Okay. Questions on any of that? Easy peasy? Excuse me. So, one other thing we want to be able to do, the last thing we're going to look at here, okay, is going to be trying to specify our line of reflection. Okay, so key thing to keep in mind here, right, is, so in other words, we'll be given our image and our original or pre-image, and then asked to figure out where that line of reflection is. All right. One tool that we have at our disposal is the mirror. We can literally just place the mirror, excuse me, in between our image and its original, and then just move our mirror until the image and original match up, and then we can just draw the line of reflection using the mirror's edge there. Okay. That's one option. Another option, patty paper. Okay, what you can do with your patty paper is, again, kind of like put your patty paper over the image and its original. Trace the points, the vertices, I should say. Trace the vertices, okay, like so. And then fold your paper so that the vertices line up, okay? So fold it so that your vertices of your shape match up to one another. Okay, like so. Whoops. And then when you open your paper back up, that fold line is your line of reflection. See, you can see it right there. To trace that line of reflection to your paper, you can put a point somewhere on that line of reflection, flip your paper over, reline things up, and then just transfer those points back over. Okay, like so. Okay, and then you can just draw through there like that. Okay, so that's another option you have there. So again, Mira, try and identify where the center is. Patty paper, trace the points of the image and the original, fold the paper, and then on the fold put some points. Flip it over, realign things, and then transfer those points. And then finally, we can also calculate it, right? We know, we know that the line of reflection is at the midpoint of the segment AA prime, BB prime, CC prime. So you can also use algebra. Okay, you see here, for the midpoint of AA prime, it's at 1, 1, and voila, there's a point on the line. The midpoint of BB prime is 0, negative 1. There it is, and then you can draw your line that way too. Okay. Alternatively, you can also come up with the equation for that line using the 2 points there too, right? Find the slope between those 2 points, and then write the equation on the line after you find the y-intercept. Well, actually, we have the y-intercept there. It's negative 1. So lots of options. Lots of options there. Okay. So again, let's go here to 12 and 13. Pick one of those two. Try 12 or 13. Make sure you're good, and then we'll get you started on your assignment here. Okay. So take like a minute or two. You can use whichever method you want to come up with the equation of your line there. Okay, 12 and 13. Do you have to, sorry?
Do you have to like write the
Equation for the line or something like that? No, you can just draw the line on there. Just draw the line reflection on there, because that's all the directions say. So you're good with that. Be hard to get your mirror to sit flat on this book too, but okay. So there we are, right? There's our line of reflection. Okay. The first one, I decided to find the midpoints of BB prime and CC prime. I got 2, 2, and 2, negative 2, negative 2, plotted those 2 points, and then drew my line of reflection there. For 13, I just used the mirror. And actually, you really didn't even need to use the mirror to reflect it. You had these 2 points that had to be on the line of reflection, right? This point didn't move. It translated from the original and it was onto the image. Sorry, transformed. And same thing here. This point stayed the same as well. So you could use those 2 points to then find your line of reflection that way too. But there it is. Okay. So that's reflections. Questions on any of that? All right. And for your homework on page 81 here, I'll get you guys started on that here, so hopefully you get some problems taken care of. All right. let's have you try. Let's just do 1 through 15 odd. Okay. Let's have you try 18. Um, 19, 20. 22 and 24. Okay. So all those, please. 1 to 15 odd, 18, 19, 20, 22, and 24. Okay, if you want to do it again, just circle those. Okay, that'll be your homework.